There's only so many of these that I can do that aren't the same after a while. And that's the whole idea here. As one of the things you guys should hopefully start to recognize is that there's really not that many, since all of the ones that we're going to be working on are always going to wind up as part of one of the special right triangles, there's only so many of those that are around. There's really only, what, 1, 2, 3 different angles before we get to the quadrantals. So if you only have 3 angles to worry about, everything else is just a variant of that. Yes, sir?
For the test 13, is it going to be predominantly non-calculated?
It'll have a mixture of calculator and non-calculator. And when we get to it, don't worry, I will explain to you guys what my expectations are. This kind of stuff, cotangent 11 pi over 6, would be a non-calculator function. The calculator stuff, we will get to probably Monday and Tuesday. Today, well, maybe tomorrow, we're going to start working backwards a little bit, also without a calculator. And then we're going to go into the actual trig applications, if you will, of how you find any angles. But then you got to use the calculator to solve simple problems. So cotangent. Cotangent is the inverse of what trig function? Tangent. Good. So we're going to start working with, first of all, finding our coterminal.
It's pi over 6.
Everybody agrees it's going to wind up being at pi over 6?
Yes.
All right. So we spin it around. We're at pi over 6. So in the first quadrant, pi over 6 dealt with which angle? 30 degree. Now there's one of two ways you can go about doing this. If you're one of the types that you start building out your own first quadrant ordered pairs set, you could go through your ordered pairs and figure that out. If you are not, and you know that it's a 30 degree angle, could you quickly just draw your triangle? And do that? And know that I'm looking at a 30 degree reference angle. And if I know that the tangent of 30 degrees, the tangent of 30 is 1 over root 3, what would the cotangent be? Root 3. So the cotangent, yeah, if you write it over 1, that's fine, okay? Your cotangent of 30 will be the square root of 3. Now, I have to, my next question then is, why is it negative? Exactly. And the reason that it's negative is because it's in the fourth quadrant. Since the sign value is negative there, cosine is positive, a positive or negative divided by positive becomes negative. Your answer is negative root 3. Again, there's a couple of different ways to set that up. Personally, I think when I'm dealing with the tangents or cotangents, I like to just quickly draw my special right triangle because I can visualize it a little bit quicker than I can working with the ordered pair sets. That's just my own thought. Okay? Does that make more sense, Dan? All right. What do you got, sir?
Well, I have a question. Are a lot of the problems that have like the same answer?
Yes, sir. Because they all want to be in coterminal. A lot of these things are going to be coterminal. If you start thinking about it, you really only have 3 angles here, 3 angles here, 3 angles here, 3 angles here. And then within that, you know, what, 12 different angles, half of them are the same value. So there's really only going to be 6 different solutions. You know, one set positive, one set negative, as you go back and forth through all those. The tricky ones will become when you're starting to work with your quadrantals again. So you have to remember how those lie on the axes. What do you want to look at as far as degree measures? Did you do okay on degrees? I'm expecting that you guys probably had a little bit easier time working with degrees than the radians. Is there any of the degrees you want to look at before we just specifically go through the radians?
Wait, yeah, can you do 47?
47? Sure. 47 is the cosecant of negative 240. So the cosecant of negative 240, again, that means it's the inverse of sine. So I'm going to go through 240. That brings me around here. Wait, no, I'm sorry, I went too far. I'm thinking 280. So it's up here, which means the reference angle is 60 degrees. Good. How many of you guys accidentally bounced one off the y-axis and got a really weird answer, or something you couldn't do? Good. That means you didn't do that. So I'm looking at, again, a 60-degree angle, and I'm looking at cosecant. Cosecant is the inverse of sine. So if you want to draw this out as a 60, oops. Sine of 60 is root 3 over 2. Therefore, the cosecant of 60
Is 2 root 3 over
2 root 3 over 3, very good. Now, in second quadrant, is sine positive or negative? It's positive because the sine is the y value. So your answer is 2 root 3 over 3. Make sense? Okay. 47, is that more? 47?
What? Yeah, that's what
All right. Any others on degrees? Are we okay on degrees? All right, let's start looking at radians then. We just did 11 pi over 6, so we got secant. Didn't we do 9 pi over 4 yesterday in secant? It doesn't hurt. I'll just bring a couple of these in here. It doesn't hurt to do them. Like I've been saying all along, this topic, this section, is one of the more important things that we're going to work on throughout this whole second semester. And it is also one of the big things that they deal with in pre-calc. Okay? When I was talking with Mr. James this morning, he was explaining to me that you guys know how we expect you guys to have, you know, the square root of 12, you know that what that is off the top of your head, 2 root 3, square root of 8, 2 root 2, things of that nature. Be able to do some simple, quick multiplying. Oh yes, you do know that. Anyway, there's a bunch of basic knowledge things that you guys have that you just don't realize you probably know off the top of your head. These basic trig functions for sines and cosines of the specials is something you're going to have to figure out off the top of your head like that. They do time tests on these things in pre-calc. I'm going to show you how they do that here in a little bit. It's not as daunting of a task as you may believe. So secant. Secant is the inverse of which function? Cosine. Good. So secant is the inverse of cosine. Did you guys pick up on the trick that if your denominator is a 4, what your reference angle is going to be? It's always going to be a 45, okay? Now 9 pi over 4 is going to spin you around into which quadrant? First quadrant. Very good, because it goes all the way around. So your first quadrant, and what's nice about first quadrant, or anything, with everything's positive, but also since you're at a 45, it's the same exact answer for sine and cosine. So if you just remember that sine and cosine are the same value in for 45s, what's it going to have to be? Root 2 over 2. So my cosine, oops, let me try this here. My cosine of the 45 is root 2 over 2. Oh, I should write it as pi over 4, excuse me. Therefore, what is the inverse of that? Root 2. Very good. And it's positive because it wound up in the first quadrant.
Oh, he didn't think about it.
Yeah. Negative 5 pi over 6. I'm going the other direction. I'm almost at a full pi. I am how far away? Pi over 6. Very good. Again, pi over 6 gives you what reference angle? It is another. It's the same thing as saying the sine of pi over 6. Now, pi over 6. Now, is that going to be 1/2, or is that going to be root 3 over 2? It's 1/2. It's 1/2. So if the sine of pi over 6 is 1/2, when I place that into the second quadrant, it is negative. Very good. It's kind of weird. Cosine 5 pi over 3. Again, as we spin ourselves around. We are how far away from 2 pi? Or pi over 3 away. We'll move my reference angle. Cosine in the 4th quadrant is what? Positive. So I know my answer is going to be a positive. Well, when I'm talking about pi over 3, is that the 30 or the 60? The 60. So what is the cosine of 60? Are you getting these right?
Yep, it is.
I accidentally thought it was negative, so I went the opposite way and got it in the first quadrant, but I still got pi over 3 and 1/2.
It's just so. Yeah, in this case here, because you might up being sine is positive in first and fourth. I'm sorry, cosine is positive in first and fourth. So if you did make that you made the wrong right mistake. Bless you. Bless you. So that's okay. The right wrong mistake or the wrong right mistake? The right wrong.
Made a mistake, so.
Yeah, there is that, but you know, you did all right.
Made the wrong mistake.
The right wrong mistake. That sounds good. Negative 17 pi over 6. That sounds like it's difficult. And it was sine, correct? All right. 6 goes into 17 how many times? 2 and 5 6. So 1 little, 2 little, 5 little, 6 pi. What's the reference? 5 or 6. Which is 30 degrees. Very good. Is it easier for you guys, instead of trying to go off the circle, to keep it for me to draw that triangle?
Yes.
Because that's something you guys already know. And as long as you understand how your radians switch back and forth into your degrees, you're okay. Remember, if it ends in a 6, it's 30. If it ends in a 3, it's 60. It's opposite what you think. So the sine of pi over 6 is what? 1/2. And we're first quadrants, we're fine.
Can we do some tangent ones?
Was there any tangent in that stuff? I don't remember if there was a tangent in there.
There's a cotangent.
There's a cotangent in there. Are we okay with secant of 23 pi over 6?
Yes.
Okay. Cosecant 17 pi over 3.
Yeah.
All right, let's look at the cotangent then.
The answer.
Yeah, I got one.
All right. 13 pi over 4. What's the denominator? So it's a 4, so it's going to be a 45-degree angle. Now let's just, if we just think through the actual idea of what this means, 45-degree angles, pi over 4, have the same sine and cosine values. That means when you take their tangent, you're always going to get 1 for an answer. It's just a matter of, is it going to be 1 or a negative 1 as you go through it. Does that make sense?
Yeah.
Whenever you're dealing with cotangent or tangent, tangent is sine over cosine.
Oh, yeah.
So now if instead of writing it out as root 2 over 2 divided by root 2 over 2, I know that the tangent is 1 over 1, or 1 over 1, depending on where I'm at. Now, yes, sir?
This is about number 57. I got negative 1/2, and I got it in the third quadrant. For negative 17.
Did I go the wrong way?
Wait, were we supposed to grab these?
I got
I got
negative
the
1/2.
Did I go the wrong way by mistake?
I think so.
Yeah, I got negative 1.
I got negative 1. I got.
No, you went the right way.
Because it's 1 pi, 2.
Yes, you're right. You're right. Yeah, I'm sorry. I went too many pi. I went an extra full pi there. Sorry about that. You guys are right. It is supposed to be third quadrant. Yes, it should be negative. Thank you. I didn't catch that. Sorry about that. I was thinking that I was still doing going the other direction where you have just a 5 pi over 6 and you're just off that little bit there. Sorry about that.
1, little 2, little 3.
That was my problem. I shouldn't be singing.
Yeah, don't
Trying to
sing.
make these things enjoyable for you.
Wait, shouldn't it be in the fourth quadrant?
Here, let's start over. I didn't do this problem yet. Let's look at it now together.
Okay, then.
All right. So
You're
when
gonna
I
make up
do
a new
this
song.
problem,
You're gonna make up a new song.
yeah, I'm gonna make
What
it.
song?
My-
I don't remember singing, him singing a song.
Well, you missed out then.
You didn't see the song?
No, I saw it.
Now we need to do it wrong again.
I was dancing. Stop talking to me.
I was playing around.
All right. Now, 6 goes into 17 twice with 5 left over.
Yeah.
So this is 2 and 5, 6, 5 pi over 6. So as we come around, there's 2 pi. Here's the 5/6. It's still the same reference angle of pi over 6, but since it is in the third quadrant, that sign value is negative. You are right. I was thinking of it as 11 pi over 6. Okay. Does that make sense how I screwed that up? Because I never screw up? Or did I do that on purpose?
I thought you were thinking of it as 23.
8. Sure.
Right?
No. Anyway, back to cotangent. So we agree that whenever you have a denominator of a 4, it's a 45-degree angle. Whenever you're dealing with tangent or cotangent of a 45-degree angle, or pi over 4, it's always going to be 1. It just depends on which quadrant you're in. Remember, tangent and cotangent are positive there, and negative in 2 and 4. So all we have to do is just map the angle. Let's see if we can do this correctly this time. 4 goes into 13 how many times?
3.
And how many are left over? 1. So this is 3 1/4 pi. 1, 2, I'm not singing. 3 1/4. So what's your answer?
Negative 1.
Negative 1. Okay. It's negative 1. The other idea that we continually understand how these things are working and how they're the values are changing as you're moving around your circle is going to really, really help you guys when we graph these in chapter 14. If Mamer was here, he can attest to the fact that knowing your ordered pairs and how they change and how they're signed SIGN, how those change as you're going around the circle, you'll notice how the pattern of the waves are constructed. It's very, very simple to work with. So let me show you guys this. Let me pause this for a second. I did not get a chance to actually just import this into the SmartBoard, so you'll have to bear with me here for a second. I'm just going to put the table in for now. Now, you guys have it a little bit differently. If you look at the bottom of your sheet, you've got the 3 grids, and you've got 2 triangles. Everybody agree on that?
Yep.
The triangle on the top, which triangle do you think that is mirroring?
30, 60, 90.
You guys are smart. Go ahead and fill in your 30, 60, 90, and your 45, 45, 90, similarly to what I've always done on the board here. And then I'm going to start explaining how we're going to go through setting up the rest. What I'd like to do here on the degree column is put in the following values. 0 and 360, 30, 45, 60, 90, 180, and 270. I'll let you guys worry about the radians here. What I want you to think of here is sine is what over what? In letters, then what do we write? Y over R. Y over R. X over R. Cotangent. Secant. And cosecant. He kind of Would you guys rather do it how we go sine, cosine, tangent, then go cosecant, secant, cotangent? You want to do it in that order? You want to? You see how it's reversed this way? What do you think would be easier for you guys to work with? It was flipped. If those two are flipped, okay. Then do this. I didn't realize that it did this. Change this one to the cosecant, and change this one to your cotangent. I think that might help alleviate some of how we, because this is kind of how we've always written it out. We put them in that order. Let me adjust this real quick.
They have a white ink.
Yep. It's really cool when you make the background black, so it's like I'm walking. I'm like writing on a chalkboard. Nothing but the fancy stuff around here, I tell you. All right. So then that way we have our r over y and x over y. Everybody okay with that?
Yes.
Okay. Now, what I'd like us to do here is briefly, before I go back to this table, I want to again reiterate how we work on our quadrantals, because it's been a couple of days since we've talked about these again. Remember, your quadrantals are the ones on the axis. You have 0, 90, 180, 270, pi over 2, pi, and 3 pi over 2. Okay? Now, when you're going through these values, again with the quadrantals, what you have to take into consideration here are your ordered pairs. When I'm on my x-axis, what is my value for y? 0. Okay? So this is something comma 0. What's the something?
No, X.
X. I don't know how far it is, it's just x. Okay? When I'm at my 90-degree angle, I'm on which axis? Therefore, which value is 0? X. So this is at 0, y. Here, it's just mirrored to the other side, so that way, what is x now? What's y? Alright. When we're dealing with the r values then, what is the value for r when you're on the x-axis? X. Good. R is always going to be x on the x-axis.
Oh, you're supposed to draw this on the.
I would do that. It wouldn't be a bad idea to put that on there. It doesn't matter. It doesn't matter. So then I know that my value of r when I'm on the x-axis is always going to be equal to x. Therefore, what's the value for r when you're on the y-axis? Very good. So what happens here is now when you start to work with your sine, your cosine, your tangent, when you're using your x's and your r's, you know what the values are all going to wind up being working via the quadrantal. Everybody all right on that so far? Wait, what? Okay. Again, if I wanted to see what the cosine of pi over 2 is, if I want to talk about the cosine of pi over 2, cosine is what over what? X over r. Yeah, adjacent to hypotenuse. So this is going to be x over r. And at pi over 2, my value of x is 0. My value of r is y. What's 0 divided by y?
0.
0. 0 in the numerator, happy. 0 in the denominator, dead.
So you put the cosine on the graph on the grid here, you put 0.
What's that?
Cosine for 90 on the grid here, you put 0.
Yeah. That's exactly right. Okay. What I'm looking at here is, as we're going through these values of these ordered pairs for all these special triangles, as we start to build it, what's going to happen is, I'm going to give you a new term here real quick. We've been calling this a revolution. one time around. Correct?
Yes.
Another term that means the same thing, a little bit more specific, is called the period. The time length it takes to do something. One revolution of what we're calling our unit circle is a period. It goes from 0 to 2 pi. As we start to take our values and we, instead of being a rotated image, we stretch it to become linear. When we stretch the image to become linear, the period in rotation here turns to this. 0, 2 pi. And that's where it ends. Instead of looking at it as coming all the way around, to do that, we just made it a linear object. We changed the shape to it. So as you're starting to walk through these things, if I'm just sitting here looking at the cosine value again, if I'm at 0, your cosine value of 0 is what? What are the values again? Is it x's and r's, or is it y's and r's? What is it? It's x over what? It's x over r. So the cosine at 0 is x over x, otherwise known as 1. So what's going to happen here, and this is kind of like getting you guys the idea of where we're going with these things, being able to pop these things out of your head, is that if I'm starting my value at 0, I can plot it at 1. And then as I go through that, when I got to 90, it was at, what was it, 0. If I get to pi, or excuse me, 180, it was at -1. I come back up here, and what we're going to be able to do is that. The unit circle allows us to be able to graph these, and that's where this is getting us. Nothing more than working with your ordered pairs. Okay? Taking a rotation, something circular, turning it linear. It's just unwinding it. Okay? We're not doing this today. I just wanted to show you why the importance of how these things flow around is important. So let's do this. Let's take a few minutes while we're still here. Oops. And I want us to fill this in. I want you guys to take a couple minutes. When you're working on your, those two leftover, what do you call them? Axes, what I'd like you to do is to start building your unit circle, one of them in degrees, and then the other one, build it in radians. Okay? Does that make sense? So you should have plenty of little bit of space here. This is, again, I want us to understand how this works, because as you start to see the pattern in here, what I'm going to be able to do is fill in a couple of these, and you'll be able to do the rest of them in a minute. That's how fast this becomes. It's become second nature. All right? We got some time in class right now. Let's do some of these, and I'll give you guys a few extra problems that to work off of for tonight. Taking a nice, slow, man, we haven't done this. This is the most time we've ever spent on one topic yet this year, isn't it? We didn't do this even for linear programming. Remember when you had to do your constraints, shade it in? The big giant word problems that everybody hated, that nobody would do. You know, got free, you had to read. When I build off the quadrantal, what I'm going to do is place 0, pi over 2, pi, 3 pi over 4, or 3 pi over 2, excuse me. When I'm doing these things, my value for x and negative x, y is 0 for both of these. Here it's 0 comma y and 0 comma negative y. When I'm on my x-axis, my value for r will always be x. Yes, sir.
And even if it is a negative x, r will still be positive.
Correct. And the idea that r is always going to be positive, because r is developed from the quadratic formula, or not quadratic. Can you imagine quadratic with this stuff? Pythagorean theorem. When you work with the Pythagorean theorem, will your hypotenuse ever be negative? It's never going to be negative. Same thing with the radius. Your radius is never going to be negative either. So your R value is always going to be a positive value. So if I want to talk about being at pi, and I want to find the cosine of pi. The cosine of pi is, well, x over r. In this case here, the value of x is negative x. The value of r is x. What's negative x divided by positive x? Negative 1, very good. If I'm going to look at the sine of it, the sine value of this is, well, at pi, y over r. Well, in this case, that's 0 divided by x. And what's 0 divided by x? Did you guys notice a little something here? Cosine of pi is negative 1. What is the x coordinate? It's the cosine. What's the sine? It's 0. Remember, your ordered pairs go cosine, sine. It'll work too.
Okay.
What I'd like you guys to work on then, with the leftover with this stuff, is I want you to do a couple more of these triangle ones out of our the ones that'll work. You should be able to. What I want you guys to work on tonight is more of those on page 958. I'd like you to do, which ones are these? These are non-calculator again.
What would we be using a calculator for at this point?
What you'll be working for calculator for is, you'll see.
We just did it on this like
That's fine, yeah. Yeah, there's 8 more of those. What I'd like you to do is 8 more of those trig functions without a calculator, all right? We'll double check our graph, our chart tomorrow. Make sure we understand how it's built again. And then we'll start working backwards on these. What I mean by working backwards is that I'm going to ask you what angle has the sine of 0. What angle has a cosine of root 2 over 2? And so on. See ya. Have a good one.
Wait.